All right, everyone. We are going to do an exam one review. So this little study guide, I'll send out in an email with the link to this video. And these are the things I think that if you all know really well, you will do well on the exam. So let's get started. First, let's talk about concepts, which is you need to understand the difference between the types of quantitative data. So interval, ordinal, ratio, know all the differences between those because he'll ask questions about that. You need to know how to calculate the mean, standard deviation, median, mode, max, range, variance, all that. But keep in mind that everything you've done so far, histograms, box plots, all of that is what we call descriptive statistics. So you're just describing data. You can't use that information to make any conclusions about anything, not unless you run inferential statistics, which we haven't done yet. So just keep in mind all of that, what we've been doing, mean, standard deviation, median, all of that is describing the data. Another concept you need to know is the normal distribution table. If you see that normal distribution table, you need to kind of understand the percentages within each intervals between +1, -1, +2, -2, like everything less than -1, everything greater than +2. You need to really understand the concept behind that. And I'll go into a little bit of that in this video. You need to understand representative random sampling. So in a perfect world, we would sample randomly and our sample would be representative. But most of the time we settle for random. Like here in the university, there are psych experiments going on. And the hope is to get a random set of participants. But how random are university students? They're all most likely going to be the same age, same demographic. So it's not really representative. And so if you want to make inferences on the general population, the state of the world, you would preferably have a representative random sampling. Theoretically, when you have a representative random sampling, you will see that the data you collect, whatever it may be, will fall into a normal distribution. The problem is it's harder to get one, like really hard. Okay. You also have to know how to read the histogram, read the distribution. Is it symmetric? Is it positively skewed? Is it negatively skewed? You have to know what that looks like, right? Okay. Now, distribution of the data set and normal distribution are two things that are different and people get confused. So let me give you an example. In this Excel sheet, this is the geography scores, right? I forgot which data sheet this is. Maybe I shouldn't use this data sheet. This data sheet right here is a list of quiz scores. There are 124 of them. And we can find percentile rank, we can find distribution, we can find what point in the data is below, the 25th percentile. But we can also do that without knowing any of these numbers. Now, we would be estimating with the assumption of normal distribution, but we wouldn't need these numbers. And that is the other part that people sometimes get confused with this, which is the normal distribution. So imagine a new set of numbers, exactly like that. Class this time, right? But I don't have the information of the data set. It's all x, 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 x. But I know that the mean is 10 and the standard deviation is 2. Well, just based off of the information, we can work with it. So if we plot that, here's the mean, plus 1 standard deviation, 2 is 12, plus 2 standard deviation, 14, 3 standard deviation, 16, minus 1 standard deviation, 8, 6, 4, and this represents the normal distribution, right? 10 is basically 0 in Z scores, in Z terms, in normalized terms, right? 8 is minus 1 standard deviation, 12 is plus 1 deviation. And if you know the normal distribution table, you would know that between 1 or minus 1 and plus 1, between minus 1 and plus 1, that's where 68.26% of the data is. So if we go back over here, right here, in the PowerPoint slide, 68.26 of the data lies within this interval on the standard normal distribution. Well, what that means is whatever this data set is, I don't know the numbers, but the fact that I know the mean and standard deviations, I can infer, or infer is the wrong word. If we assume normal distribution, then from 68.2% of the scores are between 8 and 12. But how could I possibly know that? I have no values, none, right? And so that's the difference when you're working with the normal distribution and you're working with the data set. You can still get numbers, but they're not the exact numbers of a particular data set. It's more like you're assuming normal distribution. So it's like you're assuming the general population, this is what it will look like. Okay. So now we're going to find, say, the lower, let's say 20%. So we're going to do that with the data set first. We want lower. Upper. Okay. So here, we want to know what point in this distribution is the bottom 20% of the data. And we can figure that out with the functions that he mentioned in his slides. It would be not this one, not this one. What is percentile rank? it would be this one, percentile exclude. So to find the lower 20% from this data set through Excel, percentile exclude, choose the array, which is the data set, right? Right here. I'm not going to include quiz scores because that isn't a number. If you're using a tool on data analysis tool, there'll be a box where you can check for labels because that tool has been designed to factor in labels. But if you just do equal sign functions into a cell, the regular Excel cell doesn't know it's a label. So that's why I don't include the label in here. So then once you have the array, see here, array, comma, K, the proportion. We already know the array. The proportion is 20%, which is 0.2 in proportion. 4. That means that from this set of quiz scores, the lower 20% of scores are 4 and below, right? Anything 4 or below consists of the lower 20% of scores in this data set. We want to do the upper, we can do that too. But the upper 20%, this is where it gets a little tricky, right? Because if you do, so if you imagine the normal distribution table right here, we chose to get the lower 20%, right? So it took 20% and it told us everything behind that, right? But now we want the upper 20%. So we want everything up here. But if we tell it to get, this point, it won't tell us the upper 20%. It'll tell us the bottom 80%, right? So we have to factor that in. So we're going to choose the 80% mark, right? We're going to get the corresponding number. So if the number was 10, that means 80% of scores score 10 or lower. But that means 20% of scored higher than 10. So that's what we have to do. So we're going to do that right now. Percentile, exclude, same thing with the array. There. 80 percentile, right? 13. Okay. So the upper 20% is everything. Okay. Every time I reset it, it resets the randomization. So let me. Paste only values. There. Now it's just hard numbers. Okay. So it will always be at 11 now. So this means that the number 11, 80% of scores in this data set are 11 and below, right? But that also means that 20%, the upper 20% are all greater. So that's how you get the upper 20%. Now, that's with data set. When you do a normal distribution, it's different. Here, normal distribution, we want to know the bottom 20%. Well, how do we know that? All we got is mean and standard deviation, right? We don't have any of these numbers. Sure, we know this, but what point is negative 20%? Well, that's where the standardized z-scores come in. Okay. So we are going to get the corresponding z-score for you know, the lower percent. And the corresponding z-score for the upper percent. And then we're going to plug it into this formula. Right? You put the z, you put true for cumulative, and it'll tell you the wait up. Let's do it first before anything. Oh, to calculate the z-score for lower 20%, what we do is we would use this function. Right. Get it. Oh, right here. Norm s dot inv. So norm s dot inv. I'm just gonna do that so you actually see what it is. And I'll do the actual one over here. Norm s inv. We want the bottom 20%. Right? That's 20%. This is the corresponding z-score. Okay. So that's somewhere around here, you know, the bottom 20%. That makes sense because if you look at this table or this graph, right, 50% of the data lies to the left, 50% of the data lies to the right, right? 2.5% of data lie between -2 and 3. 13.59% of the data lies between -2 and 1. So if you just see that right there, it adds up to 16%, roughly, right? So we want the bottom 20%. Well, that's like 4% to the right, because this is 16% only. Maybe a little bit more if we factor in everything over here, but it doesn't reach up to 20. So it's somewhere between -1 and 0. We know that. We just don't know what exactly. Excel tells us it's exactly -0.8416212 on the normal distribution table. So now that we have the z-score, we're going to use the z-score formula, right? We can use this formula right here to find z-score. Normally, the equation might give us a value in the data set, and then we plug that in. We subtract it from the mean of that data set, divided by standard deviation, and we get the z-score. In this case, we have the z-score. So we just do some algebra. So can't draw. Well, you get the point. Like now that we have z-score, we'll just algebraically change this up. I think I don't have to do this, but I'm just going to do it just in case. The next step, we bring the z up. No, we bring the mean over, sorry. So and so in this situation, this is what we want. In other situations, this might be what you want, right? So in this situation, we want to know the lower 20% based off the normal distribution, right? Not the data set, normal distribution. So we're going to use this formula right here. Change it to this. Okay. So we have our z-score. Value. We're going to multiply that by standard deviation, which is 2 right here, right? 2 right here. Multiply that by 2. And then we're going to add the mean, which is 10. Right? Okay, I'm going to just round this up to like there to make it somewhat prettier. There. So that's the formula to find the lower 20%. We're referencing normal standard distribution. If we actually do it out, we get 8.31676. So I'm just going to round it up to 8.32. Right. So in this data set that I do not know any values of, but I do know mean and standard deviation, I'm going to use the normal standard distribution, standardized scores to figure out the lower 20%. So theoretically, in this data set, the lower 20% of scores are anything 8.32 or lower, right? Now we want to do the same thing with the upper. So we're going to do this, right? Do it again, right here. This time 0.8. Oh, there you go. That makes sense, actually. You know, it's like symmetrical. 0, -1, +1, -2, +2. So now you just enter positive, right? So we're just going to do that again. Well, that makes it easier. I didn't think it was going to be that nice. So we can copy this here. Change it to positive to get the 80th percentile mark. You have to get the 80th percentile mark to know the upper 20. Cool. Okay. So 11. That means 80% of scores are 11.68 or lower, right? And that means that 20% of the scores are greater than. That's how you know the upper 30%. Okay. What else? Am I missing anything? Cover this, cover this. Percentile rank from data. Okay, so let's do the percentile rank function. Percentile rank function. Oh, I'm sorry. You won't have access. Well, I'll just send it to you. Okay, so percentile rank, exclude. We choose the array, A, 20, 20. right, X. So in this case, for percentile rank from data, the problem will give you a value from the data set, right? So in this list of quiz scores, it might give you 11, or let's use something else, 8, right? And we want to know the percentile rank of 8. How many people scored 8 and below? So we're going to put 8 because we're referencing that data set, so it knows to pick out 8, in its distribution. So 44 or 48.8% of people scored an 8 or lower. Right? So that's percentile rank with data. Now we want to do percentile rank with normal distribution. All right. So if we do percentile rank with normal distribution, you can obviously see the problem, which is that we don't have an array. Our array is just x, 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 right? So we have to come up with an x. And that's what we did here. We came up with an x, right? And so if they tell you to find, I don't know, percentile rank with, they could give you a z-score. Maybe they'll give you a z-score of 1.5. Maybe they'll give you a percentage, like 40 percentage rank. Well, if they give you this, then you just follow these steps, right? Instead of lower 20%, you do lower 40%, you get the corresponding z-score, you plug it into this formula, get the x, and then whatever that x is, do percentile rank, right? And so that's percentile rank from normal distribution. I'm not going to show it all the way. So I hope you understood that. If not, email me. Next is the z-score. We already went over a little bit of it because, again, many of these subjects overlap. So it's hard for me to go chronologically. So here, z-score formula, make sure you know it. I heard you get to bring in 2 sheets of notes, write all the formulas, every formula. Okay. Know how to get a z-score from a mean and standard deviation. Okay, you do. Get a z-score from a specific point in the data set. So you can do that with the, I think, this function right here. Okay, so is it this function? No, this gives you percentage. So, oh, no, sorry, this is easy. So if it gives you a specific point in the data set, like say here, gives you, I don't know, 10, tells you to find the z-score of 10 in this data set. Well, you plug 10 into here. Now, you most likely have the mean and standard deviations too. If not, calculate them. Right? Then once you do, you just take the 10, subtract from the mean, divide standard deviation, then you get the z-score. So using z-score to find percentile rank, that is what this is, right? So the problem asks you to find a z-score of 80th percentile, and you're going to use that function right there. S distribution. Z-score was 0.8, it is 9.8. It is true. So use this to use a z-score to find percentile rank. A z-score of 0.8. So z-score of 0.8, and in between here would provide you with 28.97 around of the data. Okay, so everything from this standard z-score of 0.8 right here that doesn't make sense. I put negative. Huh. Hold up a second. Wow. So I assume that when we are above the 0, Excel will give us the cumulative of everything below that. But it seems to only give you the percentage between 0 and that point. So this 28.97 percentile for a z-score of 0.8 represents 28.97% of data from right here, 0.8 to 0. So 28.97% of the data lies between 0.8 and here. And 34.3 is from 0 to 1. Right? So that's what that does. That's interesting. Specify cumulative. Oh, I didn't specify cumulative. No wonder. Okay. See, okay. So I specified cumulative, true. It changed to 78. 78. There you go. That means from 0.8 all the way down, all the data from 0.8 standard deviations above the mean to below represents 78.81% of the data. Okay. So using a z-score to find a specific data point. Well, that's just this right here. So we're getting that too. I think we went over this with the function norm s.inv. There you go. So to know the lower percent of a z-score, you know, you would say, I don't know, z-score of 1.5. Why did I write this out? Maybe it's telling you to get the z-score and it gives you percentage. Well, I think I've been talking about z-score so much that I repeated something, because I'm pretty sure everything we talked about tackled this. So I'm gonna delete this. Pretty sure we tackled it. One of these. And if you think we didn't, send me an email about with a specific question on your practice exam, homework, Excel relating to that, and I'll answer it. But I'm pretty sure I covered it. I just kept repeating things on the study guide. All right. So this is the last thing in this little review, which is applying specific formulas and Excel functions. You need to know how to use summations. So there are videos online for you to practice with different summation formulas, but you should be able to look at a summation formula and understand what it's asking of you. I made a little summation video when I was helping someone else, and you can watch it. And if it still doesn't help, send me an email. But the better able you are to know the equations, how to read equations, the better you are able to use the formulas that needs these equations and perform better on his exam, because he'll give you like equations, summation equations, and ask you to solve them, or he'll ask details about them, like what they mean, and you have to answer that. Okay. Then there's the pivot table. Know how to use the pivot table to come up with a distribution table that has frequencies, cumulative percentage. I also made a video about that. So, refer to that video. A box plot is pretty easy. If you want to do an Excel, all you do is just highlight this, insert, what is this, a little picture with the histogram right here, put a box and whisker, boom, that's your box plot. What that means is the middle line right here. I know it looks like it matches up with this. Well, it does match up with that. But point is, this middle line is the median. So, it's not exactly in the center, but that's the median point. This right here is your Q3. This right here is your Q1. We'll talk about how to get these points right now, which is this part. And so we're going to apply that part to this equation or this problem. So in your practice exam, question CA6, if you can do every single part of that question, you've hit a lot of the topics that I just mentioned. You'll have to calculate a bunch of descriptive statistics, mean, standard deviation, variance. I forgot what else, median, mode, but you have to basically do it for that problem. There's going to be summation formulas that you have to apply. You have to use the IQR equation to get the box plot, in addition to the IF formula, right? It'll show you how to get outliers. So know how to do that problem. That problem will help you a lot on the exam. So we're going to go through that problem. So he already posted the answer key, so you should be able to see this too. And we're going to work through it using our knowledge. Okay. So median. You can find the median simply by finding the middle number, but you can also do it with this formula, right? Because you're going to have to use this IF formula. I'm just going to call it IF. That's the name. Right, you're going to use this IF formula to find Q1 and Q3. And since this is the 20th percentile mark, this is the 50th percentile mark, this is the 75th percentile mark, there's no reason why you couldn't apply this formula for Q1 and Q3 to get the median, which is why you could just look at the middle number, or you could use this equation. In his answer key, he used that equation. So let's just run through that equation so no one's confused. Does it ask for Q1, Q3? Q3 right here. Okay. So it's asking for Q3 anyways. So I'm going to use that as an example. But just know for now, median's 495. You couldn't gotten that if you just went straight to the center of the data set. You could have gotten that if you use this equation, and we'll use that equation to find Q3 in a bit. Second part, find the mean. Here is the formula for the mean, right? The formula for the mean is just you take the summation of X and you divide it by 90. That's, I know that's a little complicated, like putting in that terms, but you've always done that. Like that should come naturally to you. It just, the language is not coming naturally to you. So if I give you like 5 numbers and I tell you find the average of those 5 numbers, you would just add up the 5 numbers and divide it by 5, right? And so this little complicated, way of saying it is just that. Add up all these numbers, summation, sum up all these numbers and divide it by 90, the number, right at the end. So that's what you do. You just take that number, which is the summation of all this, divide it by 90, and you get this. Mode. Mode, you're basically going to look and find the mode, which number happens most often. If you had the data set on Excel, then you can use the mode function, right, to find mode. But, it's not on Excel right here. So you have to look for it. The average is smaller than the median. This matches the shape of the histogram. If, like, this is relatively close, right? But if your median was like far off from the mean, it would not match the shape of the histogram, right? Because just know that if there's a huge discrepancy between these 2 numbers, it wouldn't match up. Okay. All right, so this is the complicated part. This is where it gets more complicated. So we're gonna use this IF formula to find the, just make it smaller right here, like this. We're going to use this formula to find the Q3. So Q3, 75 percentile, which is why the proportion is 0.75 here. Median, 50 percentile, which is why the proportion is 0.5 here. 25%, 0.25. So to find Q3, we're going to start with this IF formula. We get the integer and the fraction. So 0.75 n is 90, because there's 90 numbers in the data set. We're gonna add 1. That's the formula. So you should write it down in your notes for the exam. I'm just going to do that so that you always know what the number is or what the equation is that I'm doing. 68.25 is the IF. You're going to plug this into that main equation. So you plug this into the main equation, it would be X of 68 plus IF, the fraction, or the F, the fraction, 0.25, parentheses, X of 68 plus 1, because 68 is the I in here, 68 plus 1, 69, minus X of So here is the confusing part, which is this number 68 does not mean that X is 68. It means the 68th X, the 68th number in the data set. So if we go back up here and find the 68th number, the good thing about this kind of is that it's structured in a way where you can easily find it. Top row is 10, right? So 20, 30, 40, 50, 60. So at this point, this number is the 60th value right here, 506, 60th value. Okay, so 61, 62, 63, 64, 65, 66, 67, 68, 68. That is 68 and 69 right there. So the 68x is 512, 68th value. The 69th value is 513. The 68th value, which is 512. So that is your equation to find quartile 3. If your number was just 68, that would make it even easier because that means you have no fraction. This 0.25 would become a 0. It doesn't matter what these numbers are because whatever, anything times 0 is 0. So you don't have to worry about finding the 68th value. But you have a fraction here. So you have to do this. And so let's see what we get. $512.25, that's our quartile 3. And that is our quartile 3 right there, right? Due to it. So now it asks for interquartile range. So interquartile range right here is Q3 minus Q1. So we got Q3, but we don't got Q1. So I'm just going to do that exact same thing to find Q1. So now start again. Instead of 0.75, what will that give us? 22.75. $22.75. Now we plug that in. $22 plus 1, I plus 1. And this becomes point of the fraction right here. So now we need the 22nd value of x. Not that x is equal to 22. So 22nd. 10, 28, 21, 22. This is 22 and 23. So 4, 7, 4, 5. And 4, 7, 8, because that is the 23rd value minus 4, 7, 1. There. This is our quartile. Now we're gonna use these numbers to find the interquartile range. So Q3 So that's Q3 right there, minus Q1. Interquartile range is 35.25. Is that 35.25? Yes, 35.25. To be an outlier, a country has to score Q1. Oh no. All right, so we're gonna take a break here. This is part one. I have a meeting at 4 and I'm 4 minutes late. So I will do part 2 after I'm done. All right.